As the number of rabbits become larger, a diagram becomes too cumbersome to be useful. A table might work better. Organize your information in a table showing the number of months and the total number of rabbits for the first 6 months. So after our last problem, we know that there's 4 rabbits at 0 months. After 1 month, there was 8 rabbits. After 2 months, there was 16 rabbits. And our answer to question 1 was after 3 months, there were 32 rabbits. So just looking at these numbers, do we see any sort of a pattern? Question A says, what patterns can you find in your table? Describe the pattern of growth in words. Question B says, how does the growth in the table that you created compare to the growth patterns that you have investigated previously? Well, if we look at question B, we were used to looking at this and seeing how much it increased by. Well, this increases by 4, this increases by 8, and that increases by 16. So we know because this number is not the same, it can't be linear. Now, if we look at the second rate of growth, how much is it from 4 to 8? Well, that would be plus 4. How much is it from 8 to 6? Well, that's plus 8. Once again, this cannot be a quadratic equation because my second rate of change is not the same. So we have a whole different type of equation. So to answer question B, how does the growth in the table that you created compare to the growth patterns that you have investigated previously? So it's not linear. And it's not linear because the rate of change is not the same. So the rate of change is not the same. It's not exponential. It's not quadratic. Because the second rate of change is not the same. So the second rate of change is not the same. So we're dealing with something completely new, but do we see a pattern? If we can't add and find a pattern, what if we multiply? What do we multiply to get from 4 to 8? We multiply by 2. What do we multiply to get from 8 to 16? Multiply by 2. And how do we get from 16 to 32? Well, we can multiply by 2. So what pattern can you find in your table? We can find that if we multiply by 2, we get the next number. So knowing this, we can then multiply to finish the table. 32 times 2 is 64. 64 times 2 is going to be 128. And 128 times 2 is going to be 256. So we can complete that table. Explain why the growth rate of the rabbit is known as a multiplier. Well, it's known as a multiplier because instead of adding in our pattern, we are now multiplying. So we multiply by the same number. To get our next number. So in this case, we multiply by 2 to get the next number. So question D says, use your pattern to determine the number of rabbits that Lenny and George will have after 1 year or 12 months have passed, if every rabbit lives. So I want you to continue this pattern all the way out to 12 months and find out what that answer is. And then put that answer into Socrative. On Socrative, do not put any commas in your answer, otherwise it will not count it right.